Alright, welcome to another session. In this video we're going to talk about redox reactions. We're going to define what a reduction reaction is, an oxidation reaction is. Then furthermore we're going to talk about oxidation numbers, the rules pertaining to oxidation numbers. Then we're going to balance half reactions. We're going to balance redox reactions in acidic media and basic media. Basically that would be our roadmap. Now, the common question someone would ask is, why do substances gain or lose electrons? Why does iron rust? For your phone battery to work, why does it work? So all those questions can be answered by redox reaction. Then someone would ask, what is a redox reaction? So this word is broken down into a reduction reaction and an oxidation reaction. So the fact that it is a combination of these two words, it just tells you that these two, they are happening together, a reduction and an oxidation reaction. Now a reduction reaction in this case is just the gain of electrons, okay? Then an oxidation, here we're talking about the loss of electrons. Okay, basically that. So electrons are always transferred, from one, let me say, from one element to another. Okay, and oxidation and reduction are always happening simultaneously. One species is going to lose electrons. The one that loses the electrons is the one that we're calling an oxidized, element. Then the other one that gains, it will be the one that is reduced. So basically a good example that I can give here is, let's say I've got zinc is reacting, let's say, with copper 2+, okay? Then it gives us zinc 2+, then plus copper, like that. Okay, so now in this case we're supposed to identify which one is being oxidized and which one is being reduced. Let's look at zinc. If I get zinc here and zinc there, okay, so this zinc, you're able to see that after a reaction it is now zinc 2+, okay? So you're able to see that here it was just a neutral element, but now it has a charge. That 2+ just shows you that there's an excess of plus charges in the zinc atom. So it means we've lost 2 electrons. So I'm going to put plus 2 electrons that have been, lost. And what have we said that the loss of electrons is called an oxidation reaction. So in this case, zinc has been oxidized. Then we come to copper. Copper is 2+. It has gone to copper, metal, like that. Now you're able to see that copper initially, it doesn't have 2 electrons, okay? Now it's going to gain those 2 electrons that are coming from the zinc metal, like that. And when it gains those 2 electrons, you're able to see that now the charge has been neutralized and it has been balanced to become copper, okay? So in this case, because copper has gained those 2 electrons, copper now becomes reduced, okay? So basically that is just the basic premise about this. Now oxidation, reduction. What are just some of the basics that you are supposed to know? We are saying oxidation is loss, reduction is gain, okay? So you can use this mnemonic, rig or rig, okay? Reduction is gain, oxidation is loss, okay? Now here we're talking about loss of electrons and gain of electrons, okay? Electrons and electrons. However, oxidation can also be, defined as an increase in the oxidation number, or where you add addition of oxygen. Okay, for this other one, it is the loss of oxygen. Okay, loss of oxygen. Another definition, oxidation would be the loss of hydrogen. Okay, this one would be the gain of hydrogen. So basically those are the common definitions for oxidation and reduction. Let's have another example. Let's say this time around we have hydrogen as a diatomic molecule plus chlorine also as a diatomic molecule. Let's say we have our hydrochloric acid there. Okay, so now our question would be, which one is going to be an oxidation reaction and which one is going to be a reduction reaction? So let's first look at hydrogen. Okay, hydrogen has gone to be, after the reaction is now 2H, okay, plus. So now what has happened to hydrogen? So you're able to see that this, it was just a neutral atom, okay, but now on the other side we're able to see that hydrogen has got those 2 electrons, okay, that it has lost. Okay, so in this case what is going to happen in here, we're just going to have 2 electrons that have been lost. So this is going to be oxidized. Okay, when you come to chlorine, okay, chlorine has moved to, okay, we have 2 chlorine molecules like that. Now for chlorine to move from, initially it was just a normal molecule, neutral, but now after the reaction it has gained those 2 electrons. Okay, so because it has gained, so it means here I'm going to put 2 electrons which have been gained from the hydrogen. Okay, so in this case that is what we have. So this is reduced, okay, or reduction reaction. So basically these are just some of the nitty-gritties. Let's just solve another example on how you identify. Let's say I've got iron plus let's say 3 chlorine, let's say it gives us 2 Fe, let's say chlorine like that, 3 there. Okay, so let's consider iron. Now iron has, you're able to see that in this case for chlorine to have 3 and iron to have only 1 there, you're able to see that iron had to lose 3 electrons. So in this case I'm going to put it iron 3 plus. Okay, and then chlorine had to gain those electrons, so here I'm going to put chlorine, okay, and it went to that. So in this case this has been oxidized, this one has been reduced. Okay, so basically this is how you identify that this is an oxidation reaction, this is a reduction reaction. So basically that. Now let's solve another one. Let's say this time around you've got magnesium plus let's say HCl. Let's say you have magnesium chloride plus let's say hydrogen gas. Okay, so here we can put a 2 to just balance it. Okay, now that we've got this, let's look at magnesium. So magnesium is neutral, but after the reaction you're able to see, because of this reaction chlorine now has 2. Okay, so there was a swapping there, about valence electrons. Okay, chlorine has a negative charge, magnesium has a 2 plus charge. So there's that cross multiplication that happens. Here I'm going to have 2, here we're going to have 1, but I will not put that 1. So able to see that magnesium had to lose those 2 electrons. Okay, so because of that, in this case I'm just going to have magnesium 2 plus. this has been oxidized. Now those 2 electrons that were lost by the magnesium, they were later gained by the hydrogen. Okay, so the hydrogen, so in this case I'm just going to have hydrogen plus, in this case hydrogen went to H2 there. Okay, so because it gained, hydrogen has been reduced. Okay, basically that. Now here you should always focus on electron transfer, not just oxygen oxidation or oxygen addition. Why? Because some reactions you are not going to even have oxygen. Okay, so basically that. Okay, then to just also talk about hydrogen, we said reduction is also the gain of hydrogen. So able to see here we only have 1 hydrogen, here we've got 2 hydrogens. Okay, so basically you can also view it from that angle. Okay, let's solve another one. Let's say this time around you've got ion, let's say plus 2HCl. This, let's say it gives us ion chloride plus H2. Okay, so what is going to happen here? You're about to see that our ion there is just neutral, so I'm going to have ion there. Then we formed ion 2 plus there, the 2 plus because of the 2 there. So in this case, what am I going to have? I'm going to have ion 2 plus. Now for it to have 2 plus, it means ion has lost 2 electrons, so this has been oxidized. Okay, now those electrons are going to be gotten by the what? The hydrogen. Okay, so in this case I'm going to have H plus. The hydrogen is going to gain those 2 electrons. Okay, so this would be the reduction reaction. So basically that, and it's very important that we know that. Now how do you identify oxidation and reduction in an equation? Okay, it's also very important for us to understand. So number one, for you to be able to do this every time, you have to assign the oxidation number, which I'm just going to write as ON. Then you have to look for the increase. If there is an increase, okay, so if there's an increase, in this case it is going to be oxidation. Okay, number 2 or number 3 actually, if there's a decrease, in this case it's going to be reduction. Then after that you have to check for the electrons if they are balanced as well. So let's just solve an example. Let's say I've got zinc plus copper, the same example that we had I think initially. Let's say 2 plus, then it gives us zinc 2 plus plus copper there. Okay, so what then is going to happen? So let me just come up with a simple table for us to just see what we can do with this question. Let's say that is our table. Okay, let's say that is our simple table like that. Okay, so basically let's say this is a species that we're looking at. Let's say oxidation number. Okay, don't worry about oxidation number, we're going to talk about it as we move on. Then also the type of the reaction. Okay, so let's start with zinc there as our first element. Then we also have copper 2 plus as our first element, the reactants. So now I'm able to see that zinc, it had to move its oxidation number here, it is 0. Okay, it is 0. The oxidation number for copper there, it is a 2 plus. Okay, so I'm just going to put plus 2. Okay, that's how we write oxidation numbers. Then it has changed from what? Okay, it is 0, then it went to 2. So that's a change there. So it moved from 0 to 2 plus. Okay, or 2 plus 2. Then if you look at copper, it moved from 2 plus and it went to an oxidation number of 0. Okay, so in this case it moves from 2 plus or plus 2 and it went to 0. Okay, so by the fact that the oxidation number increased, because we said oxidation is also an increase in oxidation number. The oxidation number for zinc increased from 0 to plus 2. Okay, that is oxidation, or it means zinc was oxidized. When we come to copper, okay, the oxidation number had to reduce from positive 2 and it went all the way to 0. So because the change was like from 2 to 0, copper was reduced. So this is how I identify from oxidation numbers. Okay, so basically that. Another way, let's say we've got hydrogen plus chlorine giving us HCl. Okay, so we've got 2 chlorine molecules there. I'm going to put a 2 there. Okay, it's now balanced. Hydrogen to this side and also hydrogen to that other side. Now let's compare. I'm not going to do a table for this one, but I'm just going to compare. So I've got H2, and after it reacts with our chlorine there, it gives us hydrochloric acid. So here you're able to see that it has a charge of 0. Okay, but now it had to move to a charge of 2 plus. So you're able to see that there was a gain in oxidation number. So hydrogen was oxidized. But if you're going to look at chlorine, here it had a 0 charge there. Then it had to go to a 2 minus, because this 2 in front just means that if this is chlorine, it has a negative there and it has 2 minus. Okay, so it had to move from 0 to negative 2. Okay, so you're able to see that that is a reduction. Oxidation, the number of electrons had to reduce from 0 to negative 2. That is a reduction, or let me say a decrease in oxidation number. So because there was a decrease in oxidation number, that is reduction. Hence, chlorine was reduced. So basically, those are some of the basics that we're supposed to understand. Now that we've talked about just some basics on oxidation numbers, let's talk about oxidation numbers in this segment. So what are oxidation numbers? So a charge an atom would have if all the bonds were ionic is what we call an oxidation number. Mostly an oxidation number helps us to identify which species is oxidized or reduced, like we saw in the questions that we've solved. So the key thing is to look for electron gain or loss. Basically, that is the key thing. Now, what are some of the rules that you're supposed to understand for you to solve oxidation numbers? So an element in standard state, for example, let's say O2, a diatomic molecule, hydrogen, like that, and metals. Okay, the oxidation numbers for such is 0. Okay, then what if you have a monoatomic ion? Monoatomic ion. Okay, so for this one you are going for the charge of the ion. So for example, let's say I've got N. Okay, I've got sodium plus. So in this case, its oxidation number is just going to be plus 1. If let me say I have chlorine, okay, its oxidation number, you know that chlorine usually has a negative there, so it's going to be, its oxidation number is just going to be minus 1. Then what if we consider oxygen? Oxygen usually it is minus 2, right? Except there's an exception here. If we're talking about peroxides, for example, if I say hydrogen peroxide, something that looks like this, that is hydrogen peroxide, H2O2. Now in such compounds like peroxides, oxygen in peroxide it is negative 1. Peroxides, it is negative 1. Then if we're going to talk about hydrogen, we also just single out hydrogen. For hydrogen usually it's a plus 1, okay, except if we have what we call hydrides in metal hydrides. If we say sodium hydride, you know, metal hydrides, that's when hydrogen has a negative 1, okay. Then the sum of oxidation numbers in a neutral compound, sum of oxidation numbers in a neutral compound is 0, okay, is 0. That means that compound doesn't even have any charge. Let me say I just have CH4 like that. There is no charge attached anywhere, so this compound, this oxidation number is 0. But if we have the sum of a polyatomic, sum of let's say sum of oxidation numbers in a polyatomic ion, okay, here you get the charge of the ion itself, okay. So I can have S and there's a 2 minus. I'm going to get the 2 minus as the oxidation number for that polyatomic ion. So basically that. Let's have some examples. Let's say I've got H2O, our water. In this case we're told to find maybe the oxidation numbers for some of these compounds. So we know that hydrogen, its oxidation number is plus 1, okay. Oxygen, its oxidation number is negative 2. Now what will be the sum here? It's going to be 2, okay. I'm going to multiply this 2 plus 1, okay. Why? Because we've got 2 hydrogens. Then I'm going to add plus, we've got a minus for oxygen there, so I'm going to put minus 2. This will be equals to 0. Then I solve this equation. Now 2 multiplied by 1, that is a 2, minus a 2 is equals to 0, 0 is equals to 0. So able to see that it balances. This is we said in this case this is a neutral compound. It doesn't have any charge, so its oxidation number you expect it to be 0. Let's solve another one. Let's say I have got hydrogen peroxide, okay. So what are we going to have? Our hydrogen, we know that it is plus 1. Our oxygen, we said oxygen in peroxides, the rule is that it's going to be negative 1. Please don't forget that. So in this case, what are we going to do? I'm going to get for hydrogen, since we've got 2 of them, I'm going to say 2 multiplied by, hydrogen has an oxidation number of plus 1. I'm going to say plus 1, okay, plus, for oxygen, we've got 2 of them, so I'm going to say 2 multiplied by, oxygen has an oxidation number of negative 1 in peroxides. Then I solve these questions. Then 2 multiplied by positive 1, that will just be 2. Okay, 2 multiplied by the negative 1 there, I'm just going to have a negative 2. Okay, and the 2 minus 2, that will give me a 0. So able to also confirm that this is a neutral compound. Let's solve another one. Let's say I've got SO4, let's say 2 minus. If I've got that part as a sulfate, what do I now have? So here we have to be very, very careful. Okay, so let's start with oxygen. Okay, oxygen in this compound is going to have what? An oxidation number of -2, right? Because it's not a peroxide. What about sulfur? Okay, what about sulfur itself? So in this case, it might be very hard for us to find for sulfur, but we can solve for it. Okay, let's start with oxygen. Oxygen, we said, is -2. How many do we have? We've got 4 of them. Okay, so this -2 multiplied by the 4, okay, plus the sulfur that we might also be looking for. This will be equals to the whole charge of the whole molecule, the polyatomic molecule. In this case, it is a 2 minus. Okay, so I'm just going to put -2. Then I solve. So in this case, I'm going to have -8 plus 5 is plus S is equals to -2. Okay, now S in this case is going to be -2. I'm going to take the -8 to the other side. I'm going to have +8. Our sulfur therefore is going to be -2 plus 8. That will give me a 6. Okay, so able to see that now sulfur in this compound, it has an oxidation number of 6. So basically that, and it really makes sense. Okay, it really makes sense. So basically that, so if this has 6, oxygen has -2. Okay, and we've got 4 of these oxygens. So in this case, it's going to be 4 multiplied by the -2. That will just give us a -8. A -8 plus a 6 will just give us a -2 there. That's why it balances like that. Let's solve another one. Let's say this time around I've got potassium chromate. Okay, so in this case, what is the oxidation number for potassium? In this case, is going to be, potassium is +1. Okay, but now because there are 2 of them, I'm going to multiply this +1 multiplied by 2. I'm going to have +2 as the oxidation number for potassium. Let me come to oxygen. Oxygen in this case, oxygen has an oxidation number of -2. Now because there are 7 of them, I'm going to multiply by 7. Therefore I'm going to have -14. Okay, I come to what's this, chromate. What am I going to have for Cr in this case? Now in this case, we can just say, okay, we assume, because this is a compound and we don't have any charge there, so we're going to assume that when we solve for this Cr, we're going to let's name it as X. Okay, so in this case I'm going to name it as X, but now because there are 2 of them, I'm going to multiply this X by 2. I'm going to have 2X. Okay, now we can find for what chromium is. Okay, so in this case I'm going to have 2, okay, which is +2 minus 14 plus 2x will be equals to 0. Why I'm saying 0 is because look at this compound, it doesn't have a charge. Okay, so in this case it's a neutral compound, its oxidation number should be 0. So in this case I'm just supposed to, this is 2 minus 14. Okay, I'm going to have -12 plus 2x. Okay, is equals to 0. When I take the -12 to the other side, I'm going to have 2x is equals to 12. Okay, then I divide by 2 on both sides. X will just be equals to 12 divided by 2, that is a 6. Okay, in this case a positive 6. So basically the charge of chromium there is a positive 6. So basically that is how we solve that one. Let's solve another one. Let's say I've got potassium permanganate. Okay, so even this one we're supposed to find any of them. Okay, let's start with potassium. For potassium we're very familiar, it is a +1, and because it's only alone there, I'm just going to leave it there. Then I come to oxygen. Oxygen is very familiar, it's -2, and we have 4 of them there. I'm going to multiply by 4. Okay, then we've got manganese there. I'm just going to name it as X. Okay, and because we've got how many of them there, we only have 1 of it, so in this case I'm just going to have X there. Okay, so now what then do I have here? I have a +1, here I've got a -8. So this becomes an equation. So +1 minus 8 plus X will be equals to 0. Then I solve for X. Now 1 minus 8, that will give me a -7, plus X is equals to 0. Therefore our X is just going to be equals to 7 when I take the 7 to the other side. So for manganese there, in that compound, its oxidation number is 7. Okay, let's solve another one. Let's say hydrogen peroxide. Okay, so what are we going to have? Hydrogen, its oxidation number is +1. Okay, in a peroxide, so we always have to be very careful on that one. In a peroxide, then this multiplied by, there are 2 of them, I'm going to have +2. I come to oxygen. For oxygen, let's say oxygen this time around is X. Okay, so this X we're going to multiply it by 2, because there are 2 of them. Okay, so because there are 2 of them, I'm going to have 2X. So in this case, to be 2 plus 2X should be equals to 0. Okay, why? Because we don't have any charge there. Let's find the charge for oxygen. So in this case, I'm going to have 2X will be equals to the 2, when it goes on the other side, it becomes negative. Okay, so I'm going to have -2. Then I divide by 2 on both sides. X will be equals to a -1. Okay, so able to see now the charge for oxygen in peroxide. That's why I'm saying it is always a -1. So basically that is how you solve oxidation numbers. Now why do we talk about oxidation numbers? Because you can solve reduction and oxidation reaction using oxidation numbers. Okay, they are going to help you identify which one is an oxidation reaction and which one is a reduction reaction. So let's talk about identifying oxidation and reduction using oxidation numbers. So the steps are very simple here. You always assign oxidation numbers to all the atoms first. That is the first thing that you do. Then secondly, you identify which one increases. Okay, so if the oxidation number has increased, it means that is oxidation. But if the oxidation number decreases, that is reduction. So basically as simple as that. So we're going to go back to the first equation that we solved. We had zinc. Okay, zinc was reacting with copper. Okay, 2 plus. Then we went to zinc. Okay, 2 plus, then plus copper metal there. So for this equation, we had to even draw a table. We're not going to draw a table. Okay, The species that we have zinc and we have copper there, 2 plus, copper 2 plus. These are the species that we have. Now if you're going to look at zinc, in this case, what is its oxidation number? I'm going to write oxidation number. Okay, what is its oxidation number? The oxidation number for zinc, in this case, it is just a normal metal. We said for metals it's just going to be a 0. Okay, we come to copper. Copper already has a charge there of a 2 plus, so its oxidation number will be plus 2. Okay, then let's talk about the change now. The change in oxidation number. Zinc, let's start with zinc. Initially zinc is 0, but now it has gone to zinc 2 plus. Okay, so what is the change? The change is from 0 to plus 2. We come to copper 2 plus. Okay, it is 2 plus here, but now it has gone to copper metal there. Okay, copper metal is, it has as long as it's a metal, it's an oxidation number, it has an oxidation number of 0. So in this case, since it is copper metal, in this case we're going to have, it has moved from plus 2 to 0. Okay, now the question would be, for, let's start with zinc. Okay, the oxidation number moved from 0 to 2. Okay, is that an increase or a decrease? So it's an increase, so it means this one is zinc was oxidized. Then when I come to the other side, what is going to happen to the copper 2 plus? The copper 2 plus was reduced. Okay, so basically that is what, you know, oxidation numbers help you to, they help you to identify. Okay, so basically that. Let's solve another one. Let's say I've got chlorine. Let's say it's reacting with sodium bromide. Then let's say we have sodium chloride, then plus bromine molecule there. Okay, so basically this, now if it's balanced, I'm going to put a 2 there. I'm also going to put a 2 there, then it's balanced. Now let's just look at these molecules. Chlorine here is just a normal molecule, 0 oxidation number. But when it comes to this side, chlorine, let's say this is 0. Okay, when you go to the other side, we're going to have 2 minus 2 actually. Okay, because chlorine has a minus there, sodium here has a positive there for them to make that compound. So chlorine, you're able to see that it has moved, its oxidation number has moved from 0 to minus 2. That is a reduction, so chlorine was reduced. Okay, so this is the chlorine. Okay, if we're going to look at bromine, okay, so for bromine, okay, so here it has a charge of so here if you're going to look at this compound, it doesn't even have any charge there, so there it is 0. Okay, but when you go to the other side, our bromine there, it has a charge of now 2 plus, so because of that, from 0 to 2 plus is going to be oxidation, because the oxidation number has increased, oxidized. Okay, so basically this is what you do. So what are just some of the common mistakes that maybe someone should avoid? Forgetting polyatomic ions, that when you sum them you are getting the charge. Okay, then also misidentifying oxygen in peroxide. If it's a peroxide, oxygen is -1. Then also ignoring hydrogen rules in metal hydrides. Okay, if it's a metal hydride, there is also the way you treat hydrogen in such reactions. So basically, those are some of the basics that we're supposed to understand. Now, how do we now balance these redox reactions? It's very, very important. So there are different methods that you can use. There's the oxidation number method. You can also balance these equations in acidic and in basic media. Okay, so basically that. Now, since we're talking about us balancing equations, some of the key points that you should understand is that there's what we call the law of conservation of mass. Law of conservation of mass. Okay, another law is the law of conservation of charge. Okay, so these two laws are going to help us in balancing most of these equations. So for the law of conservation of mass does not change. Atoms on the same side. Okay, atoms should be same on both sides, on the left, on the right hand side of the equation. Okay, same with electrons. For the law of the conservation of charge, electrons must be, or they must balance on all the sides. So these are the two laws that are going to help us answer any of the questions or balance these equations. So now, as after talking about those laws, how do you balance in as using oxidation number method, the one that we're just from doing? So you have to first assign oxidation numbers to all the atoms. Okay, like we did by drawing a table if you want. Then you identify which species is oxidized. Okay, which one is oxidized, meaning there's an increase in oxidation number, and which one is reduced, meaning there's a reduction in or a decrease in oxidation number. Okay, then from that you determine the change in oxidation number. Oxidation number. Okay, then you multiply coefficients to equalize the electrons that have been lost or the ones that have been gained. So you are just getting the coefficients, then you multiply to balance off. Okay, then you have to balance the rest elements that you have, hydrogen and the oxygen. So for us to maybe understand it better, let's solve the equation. Let's say I've got the same example, zinc plus copper 2 plus, it gives us zinc 2 plus copper 2 plus. So the sum of these equations, as we start, just watch our video on electrochemistry, you're going to understand what happens on the anode and on the cathode. It's the same thing. Okay, those are redox reactions, it's electrochemistry at the same time. Basically that for a battery to be powered, it's the same thing. Okay, so in this case, let's look at the oxidation numbers. Since we're using oxidation number method, zinc, what is its oxidation number? Oxidation number, in this case zinc is 0, copper in this case is 2 plus. Then after that, zinc loses 2 electrons. Okay, it loses the 2 electrons. Then on the other side, copper gains those 2 electrons. Okay, it gains those 2 electrons. So now the question is it balanced? So able to see that everything is balanced because one is losing, the other one is gaining. So this one is just direct forward. It's already balanced, as in oxidation, using oxidation number method. Let's try another one. Let's say I've got iron, it's reacting with chlorine, and this gives us iron chloride. Let's say a 3 there. Okay, so unlike the one that was just initially balanced, this one is not balanced, so we're supposed to balance this one. So here we've got 3 chlorine molecules, here we've got only 2. Okay, so if I put a 2 there, I'm going to have 6 of them. Okay, but if I put also, I'll put a 3 there, chlorine is going to be balanced. But by virtue of me putting a 2 there in front, you're able to see that I've increased the number of ion molecules or ion atoms there, so I'm going to put a 2 there. Now when I do this, everything is now balanced. Okay, so by that, if I look at the whole equations, so here the oxidation number for ion there, it is 0. Okay, it is 0, but after the reaction happened, ion had to lose 3 electrons. Okay, it lost 3 electrons. How do I know? Because of this 3. Okay, because of that 3 plus there. Okay, it's lost 2. So there was a loss from 0 to 3. Then when we come to the other one, which is our chlorine there, chlorine here, it was 0 as well, because it is just a diatomic molecule. Then when it went on the other side, chlorine had a +1. Why am I saying a +1? Is because this one initially there was the 1 there and there was a 3 there. Okay, and they had to cross multiply like that. So from 0 to -1, actually, not really, to -1. Okay, because chlorine usually has a -1 there. From 0 to -1, that is from 0 to -1, you're able to see that an electron was gained there. Okay, so because an electron was gained there, that is reduction. Okay, so basically that. And are the electrons balanced? Of course, everything is balanced. Okay, everything, all the electrons are balanced, because the other one was losing, the other one was gaining at the same time. So basically that is how we do that one. Let's solve another one. Let's say this time around we have aluminium plus oxygen gives us aluminium oxide. Okay, so we have to look at, is this equation really balanced? Okay, so here we've got 2 aluminiums, here we only have 1. Okay, so in this case, if I put a 2 there, is it going to change everything? Okay, so let's first balance the oxygens. Here I've got 3, here I've got 2. Now if I put a 2 in front here, I'm going to have 6 of them. Then here I'm going to put a 3. Okay, I've got 3 oxygens. Now by virtue of me putting a 2 there, I've increased aluminium to 4. So therefore I'm going to also put a 4 there. Now everything is balanced. Then we have to look at the number of electrons in terms of our atoms here. If we look at aluminium as a metal, it has 4. It has 0, oxidation number. Then it literally moved from 0 all the way to 3. Okay, so it lost 3 electrons. So it lost 3 electrons, it went all the way to aluminium 3 plus. So because of that, in this case, aluminium lost 3 electrons. Okay, then when we come to oxygen, in this case, this is aluminium, this is oxygen. Oxygen here as a diatomic molecule, its oxidation number was 0, then it went all the way to, okay, you know that oxygen usually carries a 2 minus, okay, it went all the way to 2 minus electrons. Now 2 minus electrons, you're able to see when you move from 0 to 2 minus, okay, for each to have 2 minus, it means it gained 2 electrons. Okay, now the way you equalize this one, we've already put a 4 in front of hydrogen, okay, and when you come to the other side, in terms of oxygen, we've put a 3 in terms of oxygen. Now if we're going to look at the number of electrons that are involved here, okay, just for the reactants, how many electrons are there? We've got 12 electrons, okay, that were lost, okay. Then at the same time, how many electrons were gained on the other side, okay, in terms of these electrons? So also this side, we've got aluminium there are 4, oxygen there are also 3. So 12 will be lost, 12 will also be gained by the other one. So basically that is how you solve using, you know, oxidation number method. Then how do you solve using, or when you are in an acidic medium? Okay, this one is a bit different. So every time you are solving and you're balancing an acidic medium for redox reactions, you're supposed to split your reaction into oxidation half reactions. Okay, here we're talking about the oxidation half reaction and the reduction half reaction. And then after that, you are supposed to balance all atoms except hydrogen and oxygen. You balance everything except hydrogen and oxygen. Then thirdly, you're supposed to balance oxygen using water. Then you are balancing hydrogen using H plus, okay, hydrogen plus. Then after you've done that, you are going to, this is an ion, okay, so you find that you are supposed to balance charges now, okay, you are going to balance charges using electrons. Then after that, you have to multiply half equations to equalize the electrons that are there. Then you combine and you're going to cancel those ones that are showing on both sides. So let's solve an example. Let's say you've got magnesium oxide plus this manganese oxide plus, let's say, iron 2 plus, then let's say it gives us manganese 2 plus, then plus iron 3 plus. Okay, so what do? We have to make sure that we look at which one is oxidation half, which one is the reduction half. Okay, now iron here, it moved from 2 plus to 3 plus, okay, from 2 plus to 3 plus. So is that a gain or a decrease? Okay, so you're able to see that electrons there were lost, okay, for each, because it already has 2 electrons that are missing, okay, but now it has become to 3 electrons that are missing, so it has been oxidized. You can also look at it from the loss of electrons. From the gain of oxidation number, it was 2 plus, now it has gone to 3 plus. That is oxidation, that is an increase in oxidation number. So that is just the same thing. So in this case, our oxidation half is this equation, F2 plus, it went to F3 plus. Now, how many electrons were lost? Only one electron was lost. So I'm going to put only one electron there. Then we come to the reduction half reaction. Since we said these ones are redox reactions, okay, one is going to be losing, the other one is going to be gaining. So in this case, the other one, the manganese oxide, in this case it went to manganese 2 plus. Okay, so just to confirm, so here it had, if we're going to look at the charge there was a minus there. So then later on, manganese there on the other side, just manganese alone, it had to go to like 2 plus. Okay, so in terms of electrons, were they gained or were they lost? Actually they were gained. If we're going to find the oxidation number for manganese there, and we've learned how to find the oxidation numbers. So in this case, what then are we going to do? We're supposed to now balance oxygens from the manganese that we have there, okay, because we've got oxygens there. So now we're going to go to our reduction reaction. We said you balance oxygen using water, okay. So in this case, then what are we going to now do? So let me just write the equation. This is manganese for minus this, we are going to have manganese 2 plus. Okay, for us to balance this manganese there, we're going to add water. Okay, but now because we've got 4 oxygen there, I'm going to add 4 water molecules on the other side. Okay, why? Because I've got 4 oxygens there, and when I come to the other side, I've got 4 oxygens there. Okay, now that I've done that, I've introduced hydrogen in the equation. Okay, now how many hydrogens are there? We've got 4 of them. So because we've got 4 of them, I'm supposed to balance hydrogen with H plus. That's what we've said. So it means I'm going to add H plus here on the other side. But now how many am I going to add? 8 of them. So I'm going to have 8H plus there. So basically that. Then we're supposed to balance the charges. So the question now will be, in terms of charge, how much do we have on the left and how much do we have on the right? Okay, on the left hand side, I've got a -1 and I've got 8 positives. Okay, so 8 positives and a -1. What am I going to have? On the left hand side, I'm just going to have a +7. Okay, but when I come to the other side, I only have, when I come to the other side, I only have a 2 plus. Okay, now looking at the charges, the difference between the charges, okay, you're able to see that it is 5 plus. Okay, 5 plus charges, that's the difference. So it means we need 5 electrons to balance this equation fully. Okay, so now the question will be, for us to balance that, we're going to balance the one that we have on top. Okay, so that we have 5 electrons. Okay, so I'm going to multiply this equation by 1 electron, this electron from the ion, 1 electron. Then I'm going to multiply this one for the ion by 5 electrons that are missing on the other side. Okay, so 5 electrons there. So basically that, or 5 like that. Then we just need to now multiply the one that we have on top. When I multiply the one that I have on top, I'm going to have 5 Fe2 plus, this will give me 5 Fe3 plus 5 electrons plus 5 electrons. So basically this is what I have for now, and it's balanced like that. But now I'm supposed to put the reactants alone and the products alone. Okay, so in this case, if I now combine, I'm going to have 8. Okay, I'm going to have 5. Let me just use white. I'm going to have this one, and this one as the reactants. Then the products, I've got all these ones on the other side. Okay, so let's see what we have. I'm going to have 5 Fe2 plus. Then I've got the manganese there, oxide, minus. I've got 8H plus. This will give us, I come to the other side. The other side I've got a 5 Fe3 plus I've got a manganese there, 2 plus 4 water molecules. Okay, balanced. The electrons had to cancel themselves. Basically that. Now that we've got this, what then do we have? We have to balance in a basic media. So how do we balance in basic media? So let's say we have a reaction where we have let's say chromate, chromium, oxygen 7, 2 plus we've got sulfur or sulfate, 2 minus. Let's say this one gives us chromium 3 plus sulfate 2 minus. Okay, so what are we going to do? So like for basic media, you have to first split your reactions into half equations, just like in acidic media. Then you balance oxygen using water. Hydrogen, you are using OH. Okay, OH minus, because in acid we're saying an acid is a proton donor. Okay, proton donor is just like hydrogen. But when you come to basic, okay, basic, you know, it's OH, a hydroxide. So basically that. So that's how you're going to balance your hydrogen. You balance your hydrogen. The difference will only be about you balancing hydrogen. In basic, you are using an OH, which is basic. Then you balance the electrons to you multiply to equalize, and you combine. So basically, it's not that complicated. Okay, so that is what we have as our reaction. So then, which one would be the oxidation reaction? The oxidation numbers for all the compounds. You look at chromium there. So chromium there, I've got 2 of them. I'm just going to put 2x plus I've got 7. I've got 7 there, 7 oxygens. Oxygen is minus 2 is equals to 2. Okay. What is the charge for chromium exactly? Is 2 minus. So this is 2 minus. Okay, so it means we're finding minus 2. Then you solve 2x minus 14 is equals to minus 2. So in this case, when I take the 14 to the other side, I'm going to have 2x is equals to minus 2 plus 14. So 2x in this case is going to be minus 2 plus 14. That will give me what? It will give me minus 2 plus, that will give me a 12. So that will be 2 and 2. So therefore my x in this case is going to be 6. Okay, now if chromium has positive 6 here, positive 6, and it had to move from positive 6 all the way to positive 3. Okay, so from positive 6 oxidation number to positive 3 oxidation number, is that oxidation or reduction? So able to see that that is the reduction. So chromium in this case is one that was reduced. You see, this one that we have for dichromate to chromium. So dichromate 207, 2 minus, it gave us chromium like that, chromium 3 plus. Okay, that is our reduction. When we come to our oxidation, so the other one will be oxidation, but you can also try it, okay, to look at sulfur there. So sulfur here, I'm just going to put x plus oxygen. We've got 3 of them. I'm going to say 3 multiplied by minus 2. This, all of it is giving us minus 2. So I'm going to have x minus, okay, let me say plus, minus 6, okay, is equals to negative 2. So x will be equals to minus 2 plus 6. X will be equals to minus 2 plus 6, that is what? A 4. Okay, that is a 4 in this compound. When we come to the other side, we've got, let me say x plus, we've got 4 oxygens. This side, I'm going to have 4. Oxygen has an oxidation number of minus 2 is equals to, the whole compound is minus 2. Okay, this minus. So now, what then do we have? I'm just going to have, what, x, 4 multiplied by negative 2, that is negative 8 is equals to negative 2. X will be equals to negative 2 plus 8. Okay, x will be equals to negative 2 plus 8, that is a 6. Okay, 6 plus and 4 plus. Now, the question will be, this sulfur, initially it had an oxidation number of 4 plus. Then later on, it increased from 4 plus to 6 plus. So because the oxidation number increased, it means this other compound, the sulfite, was oxidized to sulfate. So oxidation is your sulfite 2 minus, it went to sulfate. Okay, so sulfite meaning it just lost one oxygen. Sulfate, it has all the oxygens. So basically that. So those are the half reactions that we have. Now if I combine the half reactions, what then do I have? I'm supposed to now balance the oxygens to balance atoms other than oxygen and hydrogen. So if I'm going to look at these reactions, here I've got 2 chlorines, I've got 2 chromiums, here I only have 1. Okay, for me to balance that, what I'm now going to do, I'm just going to add a 2 there. Okay, 2 in front here to balance chromiums there. I'm going to put a 2 there. We balance other atoms other than oxygen and hydrogen. Then when I come to the one for sulfur, is it balanced? Okay, it's not balanced because the oxygens. So that's where this one is one that we're going to balance the oxygens there. Now if I look at the oxygens there, what am I going to do? I'm going to add the water. Okay, so here we've got 3, on the other side we've got 4. Okay, so I'm going to add water on my sulfite side. So I'm S for 2 minus. Okay, this one. Okay, so basically this is how you solve redox reactions. Okay, so for other videos like electrochemistry, because it's just a build up from this topic, you can also watch our videos to just understand that part. So thank you, and we're going to see you in other sessions.